Every single time you plug something in, you're basically putting your trust in this invisible shield. And today, we're going to pull back the curtain and talk about what that is. It's called earth resistance, and it's pretty much the unsung hero of electrical safety. Okay, so just think about it for a second. We're surrounded by all this powerful electricity, right? What's stopping it from going where it shouldn't? The answer, and this might surprise you, is literally buried right under your feet. And at the heart of all this protection is a concept called grounding. I like to think of it as this silent, unseen guardian just watching over our entire electrical world. The idea behind it is, honestly, it's brilliantly simple. We literally connect our electrical systems to the Earth. Now, why would we do that? Well, because the Earth is just massive. It can soak up huge amounts of electricity without even breaking a sweat. So if something goes wrong, like a short circuit, all that dangerous energy has a safe, easy path to go, away from you and away from your expensive stuff. But, it's not quite as simple as just jamming a metal rod into the dirt. To really get a handle on how well this whole system works, we've got to break down two key types of resistance. So we've got two main ideas to unpack here. First, there's the natural resistance of the soil itself. And second, there's the resistance of the actual connection to that soil through what we call an electrode. Now, they sound super similar, I know, but trust me, understanding the difference between them is absolutely everything when we're talking about safety. All right, first up is soil resistivity. The easiest way to think about this is that it's just a natural property of the ground, kind of like its color or how it feels. It's a measure of how much a 1 meter cube of that exact soil fights against electrical flow. And of course, different types of soil, sandy, clay, whatever, they're all going to have totally different resistivity values. Okay, now for the one that really matters for safety, earth electrode resistance. And here's the crucial part, so listen up. We're not actually measuring the metal rod itself. What we're measuring is how well the soil surrounding that rod can carry electricity away from it. That single number tells us exactly how strong our invisible shield actually is. So, if this resistance number is so important, what actually affects it? Can it change? You bet it can. It turns out the ground under our feet isn't static at all. It's a really dynamic environment. It really comes down to three main things. First, how many conductive salts are in the soil? Second is the moisture level. How wet is it? And third is the temperature of the soil. Now, check this out, because this is a fascinating little detail. Temperature has a huge impact. For every single degree Celsius that the ground warms up above freezing, its ability to conduct electricity gets better by about 2%. How cool is that? It's because that extra warmth lets the ions in the soil's moisture just move around more freely. And when you think about that over the course of a whole season, that can make a massive difference. So the good news here is that we're not just stuck with whatever resistance value nature decides to give us. If a measurement comes back and it's too high, we can actually do things to lower it. You can drive the electrode deeper into the ground, you can add more electrodes, or you can even chemically treat the soil with electrolytes to make it a better conductor. And yeah, using more than one electrode, it makes a huge difference. I mean, just look at this drop here. Adding just a second electrode can slash the resistance by almost 40%. And then if you double that to 4 electrodes, you get an even better connection. So when it comes to grounding, there is absolutely strength in numbers. Okay, so we've covered what earth resistance is, and we know what can affect it. But that's all just theory, right? How do the pros actually go out there and measure this invisible force to make sure we're all safe?
Well, the whole principle is actually based on good old Ohm's law from physics class. It's pretty straightforward. You push a known amount of electrical current through the ground electrode. Then, you measure the voltage change that happens in the soil nearby. And finally, you just divide that voltage by the current, and boom, that's your resistance.
The go-to technique, the one everybody uses, is called the fall of potential method. This is the industry standard. It's the most accurate, most reliable way to get a true reading. And it involves carefully placing some temporary rods to measure that voltage drop in the soil. Now, there's also a little shortcut. When you're out in the field and you need a quick reading, engineers will sometimes use something called the 62% rule. It's a faster, way more simplified version of the main method. But, and this is a big but, it's just an approximation. The results always need to be verified with a proper, more thorough test. And of course, the real world is messy. It's not always a perfect open field. So there are all these other specialized methods for tricky spots, like in a dense city where you can't just start hammering stakes into the sidewalk, right? Or on a really complex industrial site. It just goes to show you how seriously engineers take this stuff. They've got an entire toolkit just to get the measurement right. So, let's bring this all home. We've talked about the soil, the electrodes, the ways we measure, but what does it all boil down to? Really, it's all in service of one single goal: making sure we have a powerful, reliable, and most importantly, safe connection to the Earth. And that really is the bottom line. All this theory, all these tools, they exist for one reason and one reason only: to make sure that when things inevitably go wrong, our grounding systems work perfectly every time. Because without that proper measurement, that invisible shield we've been talking about, well, it might just not be there when you need it the most. It kind of makes you think, doesn't it? Grounding is just one of these amazing, invisible systems that's constantly working to keep us safe. It makes me wonder, what other unseen guardians are out there protecting you right now that you've never even noticed?